So we are doing 10.3b, second part of our lesson about geometric sequences and series. So we did sequences last time. We are now talking about geometric series. And if you guys remember, series just means you are adding up the terms in the sequence. All right, you're adding up the terms. And I have two formulas for you. All right, two formulas for you that actually find the same thing. All right, this is to find the sum of n terms in your geometric sequence. But the reason why I have two formulas for you is because it just depends on what you're given. If you're given certain things, one formula will be better to use than the other. So that's why you got two formulas for this. Okay, so the first formula, I personally like the best. I use this one the most. This is when you're given a sub 1 and n. All right, if you're given a sub 1 and n, you can use this formula for the partial sum. Okay. All right, so that's a sub 1, the first term, minus a sub 1 times r to the nth power all over 1 minus r. Another way I've seen this, and I actually tend to like using this way better, is I think of this as a sub 1 parentheses 1 minus r to the nth power all over 1 minus r. So I'm basically like factoring out that a sub 1. Sometimes I find it easier to use this formula in this form. So I like to use it in this form instead. But I think your book has it in the other one. So choose whichever one you want. All right. The second formula, still to find the same thing, the partial sum. This time, if you're given a sub 1, the first term, and a sub n, the last term, you can use this formula right here. All right. It looks very, very similar, but there's a couple of key differences. All right, so let me zoom in so you can see all those little details. Really, it's just this term that's different. All right, this last term, this is the a sub n instead of a sub 1. And it's just times r. There's no r to the nth. Okay, so the only difference is this last term. Everything else is the same. All right, so let's play around with these formulas, kind of get a little more used to this. So I'm going to call on somebody. Just tell me what you think you would do. We're just practicing using these formulas. Okay? All right, so number 1, find the sum of each geometric series. Find the sum of each geometric series. All right, let me go Jaden. Jaden, what do you think? For number 1, what would you do? Which formula would you use? How would you use it?
The first one.
Nice. I think I would use the first one too. Okay, so let's plug in stuff. So I want to find the sum, and go ahead and plug in what you need to plug in.
So it's 36, and then parentheses 1 minus r,
Which is
1/3
good.
to the power of 8,
Perfect.
and then over 1 minus 1/3.
Perfect. Nicely done. All right. That is how you use that formula. You just kind of plug everything in. Now, the tricky part is actually typing this into your calculator. Funnily enough, the calculator part is actually the trickiest part. The reason why is because your calculator doesn't know PEMDAS. All right, so you have to type this in the order of PEMDAS to get the correct answer. So let's try it. Plug this into your calculator. Let's see if we get the right answer. Type it in the chat. Once you have it, I'll verify if you got it right. All right, go for it. Okay, so to show you how I would do this, since I think most of you guys got it, but some people are getting slightly different answers, I would do the exponent first. So 1/3 to the 8th power, I would get that answer. And then 1 minus that answer. All right, so that's the parenthesis, times 36, okay? And then divided by 1 minus 1/3, which is 2/3. So parentheses, 2/3. Okay, so that should be your final answer, 53.9918. 53.9918. All right, any questions about that? Okay, nice, guys. So this one, again, was 53.9918. And in case you did number 2 or you just need to practice, using the calculator more, the answer for number 2 is 831.855. So feel free to try number 2 on your own, and just make sure, your calculator stuff is all working good. Okay, let's try number 3. Number 3, this time they give it to us in sigma notation. So remember, sigma notation, this means sum. So we want to add up all these terms as we're plugging in k. 1, 2, 3, 4, up to k is 5. Okay. I'm actually going to show you guys number 3 and 4 using both formulas. And that way, number 5, I'm going to have you guys choose which formula you like better. All right, so choose your own adventure. Look at how I use the formulas for number 3 and number 4. Okay, so number 3, let me just use the second formula since we haven't used it yet. All right, so for the second formula, I need a sub 1. I need a sub n, and I need r. Okay. A sub 1, I'm going to plug in k is 1 into that function. All right, so -3, 4 to the power of 1 minus 1. That just gets me -3, because 4 to the 0 is just 1. 1 times -3 is -3. All right, to get to my last term, I'm going to plug in 5 in for k. So I'm going to plug in -3 times 4 to the 5th power minus 1. Use calculator on this. 4 to the 4th power is 256 times -3. And yes, you will get a calculator on this quiz. Don't worry. And I get -768. Yes, you can use the bathroom. All right. So -1 is my first term. -768 is my last term. Now R. R is actually really easy to find when it's in sigma notation like this. R is always going to be your base number to the k exponent, right? So wherever k is the exponent, the number that's the base, that is your R. All right, so no work needed. For that, R is just 4. All right, so we can just plug this in to our formula. So I got -3 minus -768 times 4 all over 1 minus 4. All right, and then one of the benefits of using this formula is
Miss L,
oh yeah, question.
how do you get R equals 4?
Yeah, so R is 4 because R is always going to be the number that is the base of the exponent k.
Oh, okay.
Okay. All right, so then answer I got was -1023. One of the good things about this one is it's a lot easier to simplify on your calculator. So that's one of the pros to using this formula. All right, number 4. Let me show you this now using the first formula. All right, so the first formula, I'm going to need a sub 1 still. I need r, and I also need n. All right, so those are the variables for the first formula. A sub 1, I'm going to plug in my first k. So this time k is 3. So I'm going to plug that in. And that just gets me 4 times negative 1 to the second power, so that's positive 1, so that just gets me 4. R is just negative 1, because again, it's just the number that's the base of the k exponent. And n, we did this before with arithmetic series, is your 10 minus 3 plus 1. All right, so that's this top number minus the bottom number, but always add 1 at the very end. All right, so that gets me 8. Okay, so using this formula, I get a1 times 1 minus r to the nth power all over 1 minus r. All right, so this is going to be 4 times, this is 1 minus, negative 1 to the 8th power is just positive 1. So this ends up just being 0. All right, so I think the pro of using this formula is that these are a lot easier to find, right? A1, R, and N, especially R and N. These are just easier to find, though it's kind of a little bit harder to simplify at the end. So really, you guys can choose which one plays to your strengths. Okay. So try number 5. Use whichever formula you feel comfortable with, and put your answer in the chat. All right, go for it. Okay, so to do this with the first formula, I'm going to find same variables, A1. Let me use a different color. A1, R, and N. A1, I'm going to plug in my first K. So they're starting K at 3. So I'm going to also plug in 3. And I get negative 25. R is just 5 because that's the base of K. And N is going to be 7, my top number, minus 3 plus 1. So that's also 5. Oh, yes, you can use the bathroom. All right, plugging all that into my formula. This is going to be my first term, negative 25, times 1 minus R to the N all over 1 minus R. Okay, so plugging that all in, I got negative 19,525. Okay, questions after you guys tried it? Did that unstick you if you were stuck? Let's see. In the first formula, does a sub 1 occur twice? If it does, then why don't we see the same number appear twice? Ooh, yeah, good question. So there's 2 versions, I guess, of it. I used this one. So that's why a sub 1 only happened once, because I did parentheses, 1 minus r to the n power. But if you didn't do it, you could use a sub 1 twice like that. I tend to like using this one better. I think it's easier to handle than this one. So, yeah. But good observation. Nice. Oh, you put negative 1 instead of negative 25. Got it. Will we be asked to specifically use one of the formulas over the other online test? Nope. You can use whichever one you want. Yeah, use whichever one. Okay, let's go into our last part. And this really shows how knowing both formulas are really, really useful. All right, so don't think, oh, I'll just use one formula and ignore the other one. That actually could be a little detrimental because there are specific cases where one formula really, really does, like, you need to use that formula. Okay. So for example, so number 6, it says find a sub 1 for each geometric series described. Okay, so number 6, they give you the sum, they give you n, and they give you r. So we can actually use our formula the first one and just kind of plug in everything to solve for a sub 1. All right, so plug in your sum is 720. You're looking for a sub 1. R is 3. N is 4. And then 1 minus 3 on the bottom. All right, so you just plug it in and you solve. From here, I would simplify the parenthesis. And you do 1 minus 3 to the 4th power, which is negative 80, all over negative 2. And well, since negative 80 and negative 2 divide really easily, I will divide that. So I get 40 a sub 1 is equal to 720. And a sub 1 is equal to 18. All right, and that's it. Okay, so for first formula, definitely a lot easier to use for this one. Number 8. Number 8, this is a situation where you really want to use the second formula. The reason why is because they give you the sum, they give you R, and they give you this last term. If you really, really wanted to use the first formula, you would have to like find out what a sub 1 is based off of these two things. All right, and that is a lot more work. So instead, let's just use the second formula. So S sub n is equal to a sub 1 minus a sub n times R over 1 minus R. Plug it all in. And be careful with those negatives. All right, so let's simplify that. I get negative 6,552 is equal to a sub 1 plus, since negative times a negative will give me positive. Multiply 4,374 times 3, I get 13122 over negative 2. And I'm going to multiply that to go on the other side. So that gets me 13,104. And then I can subtract the 13,122 on both sides. That gets me negative, 18. All right, that's a coincidence that it's so similar to this one. All right, that is just purely coincidental. Okay, any questions on those? All right, why don't you guys try number 7 and 9? 7 and 9. Go ahead and give that a try and then put both answers in the chat once you're done. Okay, Zach, go for it. Number 7.
So first I got negative 936 equals to a sub 1 minus negative 750 times 5 over negative 4.
Oh, wait. Number 7. I think you're doing number 9.
Oh. Okay, so for number 7, I got 29,127 equals to a sub 1 times 1 minus 4 with the to the 9th power over negative 3.
Good, nice.
And then I multiplied both sides by negative 3. So I had negative 87,381 equals to a sub 1 times 1 minus 4 to the 9th power.
Perfect.
And then I got rid of the exponent, and I had in the parentheses 1 minus 262,144.
Got it. Okay.
And then so I had the thing on the big number on the left equals a sub 1 times negative 262,143.
Got it.
And then I divided that out, and and I got A equals 1/3.
Perfect. Nicely done. Awesome job, Zach. Cool. All right, let's do number 9. Summer, you ready for that one?
Yeah.
Okay, perfect. Go for it.
Okay, so I plugged in negative 936 into the equation, and then A1, I just did plus 750 times 5.
Perfect, because yeah, negative times the minus gets you plus, so might as well.
Yeah. And then over 1 minus 5.
Cool. Okay.
And then I simplified, so it would be negative 936 equals A1 plus 3,750 over negative 4.
Mm-hmm.
And then I times negative 4 on both sides to get 3,744 equals A1 plus 3,750.
Perfect. Uh-huh.
I subtracted and got negative 6.
Awesome job. Nicely done, Summer. Okay. Got it. Any questions? Let me see the chat. Let's see. For number 9 is A sub 1 negative 6. Oh, yes. That is the correct answer. Nice. Good job. All right. Other questions, number 7 or 9? Okay. I would find more often than not, if you are not getting the right answer, it usually is just like a careless mistake with like PEMDAS or simplifying. So I think that's just, comes with practice and getting used to these formulas. Okay. All right, guys, let's get to our last question. Let me have Mason. Can you read this one out for us? A teacher teaches.
A teacher teaches 8 students how to fold an origami model. Each of these students goes on to teach 8 students of their own how to fold the same model. If this teaching process goes on for n generations, how many people will know how to fold the origami model?
Awesome. Mason, have you ever done origami before?
Not really.
That's my attempt at drawing a origami duck. Oh, sorry, I'm reading in the chat. Oh, yes. Just yeah. Be careful when reading the problem. All right. So yeah, basically what they're saying is you have one person, a teacher, who knows origami. That teacher is going to teach 8 people, right? So in the next stage, like 8 more people will know how to do origami. And then each of those 8 people will teach 8 more people. So then 64 more people will know how to do origami, right? This is also known as a pyramid scheme, if you know. Okay, so basically you have a geometric sequence where R is equal to 8. All right, and the question is, if this teaching model process goes on for n generations, how many people total, I'm going to just emphasize that, how many total people will know how to fold origami? All right, so basically we're adding up, how many people know origami. So this is going to be the sum model. And again, I like using this formula the best. And I think it's appropriate for this one because it's easy to find A sub 1, R, and N. So N actually stays N, right? Because they want it for N generations. So N is just going to stay N. So I just need to find A sub 1, which is just 1. And R is 8. So if you just plug those in, now you just simplify. All right, so this is S sub N is equal to, well, 1 times that is just 1 minus 8 to the n power. And simplify the denominator, you get negative 7. All right, So you can leave it like this, or if you want to be fancy, you can multiply top and bottom by -1 and clean it up a little bit. And you can do it this way. All right, so either of those will work. All right, good job, guys. That is the lesson.